All right, this video is going to go through numbers 9 through 16 in the topic 11 test review. So starting with number 9, we have a steel pipe that's 50 centimeters long that has an outside diameter of 3 centimeters and an inside diameter of 2.2 centimeters. So let's just kind of figure out what that drawing really means. So if I have a pipe, that's something that I can think of as a cylinder. Okay, so I've got a cylinder. It's essentially a hollowed out cylinder. That's why they're giving me two different measurements. So the 5 centimeters long is actually 50 centimeters long is actually the height of the cylinder. So even though it's horizontal, right, that's that length of the curved part. And then they're telling us that it has an outside diameter of 3 centimeters. So again, that's because this thing is hollowed out. So this is 3 centimeters, which means that it has an outside radius of half of that, of 1.5. And then it has an inside diameter, use a color that's a little further away from blue. So then an inside diameter of 2.2 centimeters. And so that means that it has an inside radius of 1.1 centimeters because it's half of that. So I want to find the volume of this shaded portion. So that doesn't mean that I can subtract my 2 radii, because what would happen if I did that is I would find the volume of some smaller cylinder. Right, so I don't do 1.5 minus 1.1 because that would create the smaller cylinder. I have to subtract the actual volume. So I want to subtract the volume of the whole thing minus the volume of the inside part. So it's like it's drilled and hollowed out. Okay, so since they're both cylinders, we're going to use the volume formula on the back, or the front, I should say, which is V equals pi r squared h. So we already know R and H for each piece because it's all 50 centimeters long. Then it's asking us to find the density. So for our answer, we're calculating oh no, sorry, it's not asking us for the density. They're telling us the density of steel is 78 grams per cubic centimeter. They want us to find the mass of the pipe using the formula mass equals density times volume. So our mass is going to be equal to that 7.8 times the volume that we get. And our answer is going to be to the nearest gram. So we're going to have an answer in grams for this problem. Okay, so let's calculate each of the volumes of the cylinders so that we can find that density. So for the outside cylinder, the radius is 1.5, so the volume is going to be pi times 1.5 squared times 50. And so if we type that into our calculators, that gives us, that gives us about 353. Let's just say 0.43. And then we want to do the same thing with the inside cylinder. So volume is still pi this time times 1.1 squared times 50. And so that is going to give us pi times 1.1 squared times 50. Sorry. About 190.07. And so then that means that the volume of the entire pipe is going to be the difference of those two volumes. So I'm going to take the 353.43 and subtract the 190.07. Which gives us about 163.36. So if I multiply 163.36 times 7.8 to figure out the volume, that gives me 1,274.2. So that's going to round and to keep it at the 4. So 1,274 grams is the answer for number 9. The volume of prism A in number 10 is 72 cubic units. So they're telling us that this is 72 cubic units. And the volume of prism A is twice the volume of prism B. So that means that prism B's volume is 72 divided by 2. And so that means that's 36. It's asking us what is the value of A. So when we have a prism, remember that volume is equal to the area of the base times the height. The base for this prism is this square down here, not a square, sorry, this rectangle here that has the dimensions 3 and 4. So that means that the base area for this is 3 times 4, which is 12. So if my volume is 36, the area of the base is 12, and I want to find the height A, I'm just going to divide both sides by 12, so that tells us that A is 3. Okay, so then number 11 is like our homework problem number 20, where we had a stack of nickels. In this problem, though, it's just a stack of cookies. So if I think about a stack of cookies, I can think about it as though it's a cylinder, right? So if I have a stack of cookies, they're round. There are 12 cookies, because it says 1 dozen, has a volume, a diameter of 2.5. centimeters, and it fits exactly in a cylindrical container of volume 14.726 cubic centimeters. So if I can think about a cookie, I want to model that as a cylinder as well. And so when I'm looking for a cookie, its thickness, I'm looking for the H, right? So thickness is going to be the height of the cookie in a cylindrical model. And so since this volume represents 12 cookies, what I want to do just to start off is to divide that number by 12. So I'm going to start with 1 cookie. Whoops, an extra O. 1 cookie's volume is going to be the 14.726 divided by 12, because there's 12 cookies in the container. So that means that this 1 cookie's volume is going to be 1.227 cubic centimeters. I'm going to use, again, a cylinder to model 1 cookie. And so 1 cookie's volume is going to be represented by pi times r squared times h. Since I want to know h, I know that's a variable. If my diameter of the the diameter of the cookie is 2.5, that means that the radius is 1.25. So I'm going to use 1.25 as the value for the radius. And so to solve for h, I'm going to start by dividing both sides by pi. And so that gives me, I guess I should say about at this point, that gives me about 0.391. And then I have 1.25 times squared times h. So if I square that, that's 1.5625. Okay, so 1.25 squared is 1.5625. And then if I divide both sides by that number now, 1.5625, that's going to give me the height of one of these cookies. And so the height of a cookie is about 0.25 centimeters. Okay, so again, it works just like the nickel problem where they're giving you the volume of a stack. So you have to divide that volume by however many are in the stack. And then you're setting that equal to the volume formula for a cylinder with the radius plugged in order to solve for the height. So our cookies have a thickness of 0.25 centimeters because the height of the cylinder is that number. For number 12, we have the height of a square pyramid is 1/2 the length of each side. So they're giving us a ratio of the two sides together. So if I have a square pyramid, the volume of a pyramid is 1/3 the area of the base times the height. Since it's a square, the area of the base is s squared. So the formula for a square pyramid is 1/3 times s squared times h. They're giving us a relationship between the height and the side. So they're telling us h equals 1/2 of s. So what we can do then is plug 1/2 s in for h. And then they've given us a value also for the volume. So they said that the volume of the pyramid, so we can plug in that number for the volume. So we're going to use this equation, and then we have to figure out s to then find the height of the pyramid. So we're going to use this equation to find the height. Our height is going to be something in inches because we have excuse me, cubic inches for our volume. So we're going to plug in 2,304 is equal to 1/3 times s squared. And then remember for h, we're plugging in times 1/2 s. So that means that we've got 2,304 is equal to, if I multiply the fractions together, that gives me 1/6, and then the s's together, s cubed. So to solve for s, what we need to do is multiply both sides by the reciprocal of the fraction, so by 6/1, so that those numbers reduce away. So s cubed is equal to 6 times 2,304, which is 13,824. So since s is cubed, we have to take the cube root to determine the value of s. So the cube root, oh, I didn't change the colors, one sec. The cube root of both sides tells us that s is about 24. Or s is 24. Okay, so then if h is 1/2 of s, that means that half of 24 is 12. So the answer is that the height is 12 inches. Number 13 gives us a regular octahedron. So it's called an octahedron because it has 8 triangles as its faces. It says each edge has a length of 4 centimeters, and h in the diagram is equal to 9 centimeters. What is the volume of the octahedron? And so even though it's called an octahedron because it has 8 triangular faces where they're equilateral triangles. So it's telling us that each of these edges is 4 centimeters, right, all the way around. So these are equilateral triangles with 4 centimeter edges. There's 8 of them, hence the name octahedron. What I want you to think about it, though, is if you think about the bottom and the top separately, this is actually a square pyramid. So the easiest way to think about this is as though we had 2 square pyramids. So whatever the volume of one square pyramid is, I'm just going to use double that value. So I'm going to multiply it times 2, right? Whatever the volume of a square pyramid is. And so we just did that one in the last problem. So remember that for a square pyramid, or for a pyramid, we're using volume equals 1/3 area of the base times the height. And because it's a square as our base, right, 4 sides of 4 all the way around, the area of the base is s squared. So we're going to use that formula. So 1/3 times s squared times h. And so if we look at the side lengths, right, the side length is the s, and then h is given to us in the diagram. So we're going to do 2 times 1/3 times 4 squared times 9. And so since we have some whole numbers, it's easier to kind of simplify before you multiply. So since I have 1/3 times 4 squared times 9, I can reduce the 9 with the 3 and the 1/3. And so if I divide those both by 3, I get 3/1. So now I've gotten rid of the fraction, and I just have numbers to deal with. So what I really have here is 2 times 16 times 3 to determine the volume. And so that means that the volume then is 96, and our units here were centimeters, so that's cubic centimeters for the volume. Okay, so again, even though it's showing you this regular octahedron, 8 equilateral faces, think about it as though you have 2 square pyramids with a base of, with the side base of 4 centimeters, and then the height of the pyramid is the number given, 9. For 14, we have a cone, and this is a straightforward problem too, where actually even more straightforward because we're given everything that we need. So if we have a cone, on the other side of the paper, the volume formula for a cone is 1/3 pi r squared h. So if we look at the diagram, r is 3.4 feet. The height is 4.8 feet. So we're just plugging those values into the volume formula. So 1/3 pi times 3.4 squared times 4.8. So again, this is a problem where you need to show that you plug that in, and then all you have to do is calculate it to find the answer. So make sure that you're writing down everything that you're typing into your calculator, but you don't need to show any simplification steps for that. So if you do 1 divided by 3 times pi times 3.14 squared times 4.8 and just type it straight in, you get about 58 point, let's see, it says round to the nearest hundredth. So let me check what that is because I didn't round to the nearest hundredth. So I've got 1/3 times pi times 3.4 squared times 4.8 is 58.11. So it's 106. That 6 is going to round that up to 11, and then it's square cubic feet. Okay, so remember, hundredth is 2 decimal places. Everything else here, for the most part, was 1 decimal place. It said tenth, or it'll say to the nearest whole value, so you aren't ignoring decimals. Okay, 15, a pile of earth removed from an excavation is a cone measuring 12 feet high. So they're saying that we have a pile that is in the shape of a cone that is 12 feet high and 30 feet across its base. How many trips will it take to haul away the earth using a dump truck with the capacity of 216 cubic feet? So what we're gonna have to do then is find the volume of the pile. And then once we found that value, in order to find our answer, the number of trips, will be equal to whatever our volume is divided by that capacity. So we're gonna have to divide by the 200. Sorry, I thought I changed the color and I didn't. We're gonna divide by that 216 cubic feet to figure out our answer. So our answer is going to be related to that 216. What we have to do first though is calculate the volume of the pile. So since it's a cone, we're still using that cone formula. So 1/3 times pi times the radius squared times the height. And so we are given the diameter, not the radius. So that means that the radius is half of 30, so 15 feet. So we're gonna do 1/3 times pi times 15 squared times our height of 12. And then we can simplify this beforehand if we want to, because 1/3 of 12 is 4, so that there's a little bit less to calculate, or you can just calculate straight in. Okay, so that's your choice. You can either reduce the 12 with the 3 or not, because then you're just doing pi times 15 squared times 4. So with that, your calculation for the volume should be 2,827.4. So I'm going to take that number and divide it by 216. And so that gives me a value of 13.1. So remember that I need to move the whole pile away. So I'm always going to round this up. So that means that I have to go 14 trips in order to move the entire pile of earth. So when I'm moving a pile, I have to round up every time, okay? So we're not rounding down to 13, we have to round up to 14 because everything needs to disappear. For 16, we have a basketball with a diameter of 9.5 inches is placed in a cubic box with sides 12 inches long. How many cubic inches of packing foam are needed to fill the rest of the box round to the nearest tenth? So we have a basketball with a diameter of 9.5 inches. So let's figure out that volume. So the basketball, we can use a sphere to model that is 4/3 pi r cubed. So since they give us diameter, this means that the radius is half of 9.5. So the radius is 4.75. So the volume is going to be 4/3 times pi times 4.75 to the third power. And so that means that we can estimate the volume of the basketball as 448.9 cubic inches. Since the box is a cubic box, what they're telling us is that all of the dimensions are the same. So the best way to think about the box is that its volume is just the sides to the third power. So in general, we've talked about the idea that for a box, it's a prism. So it's the area of the base times the height. And so what we would do with that is the base is a square, so it would be s squared. And then the height would actually be the same number. So technically we could do 12 squared times 12 to model that, but recognizing that if it's a cube, all three sides are the same, and just raising that number to the third power, that's an easier way to identify the volume of a cube of some sort. And so 12 to the third power is 1,728 cubic inches. So then the packing foam, I'm just going to write foam, is going to have to fill the space that is the difference of the two. So I'm going to do the box minus the basketball. And so that means that we're calculating the difference of 1728 and 448.9. And so if we subtract that, that means that the foam will take up about 1,279.1 cubic inches. So one thing to make sure of when you're taking this test, again, is that you're writing down the numbers that you've plugged in. If anything is a like straight, find the formula, find the volume using the formula. So we need to see what numbers you plugged in and what your answer was. I know you can just type it into the calculator looking at the problem, but you're not going to earn any points for a problem that just has values written down and doesn't show us what formula you used and how you process that. Okay, so you need to make sure that you're showing all your steps, or else you're not going to get any points for the problems. These same formulas that are on the front will be on your test. Also, a reminder will be there to tell you that you need to write down your work. Remember that these things that I wrote in blue are things that you need to know, that capital B represents the area of the base, that the formulas below there are things that will be commonly used, and that faces plus vertices equals edges plus 2. So that's all for the topic 11 review.